All right, the kind of problems that you're going to do in here, it's probably something you haven't seen before. They're called operations research problems, or OR problems for short, because we add acronyms here. But there's like pieces to it, and you're going to read in the next section. And I'm not that jazzed by business problems, like they don't really like interest me, but it might interest you guys. So I'm going to sometimes go through exactly the problem they have in the book. But that's applicable to a lot of places. So the sample size question falls into this OR category. And OR, we have one part of it where I think of it as a slider. Well, I can slide this amount back and forth and ask questions about what's best. So the slider is called the decision model. So that's how many people should I enroll? That's the decision model. So in your book, in the reading for Friday, they talk about this, the decision model. And I think on Monday's class, they talk about this again. So at the end of this class, everybody will know really what a decision model is. But piecing it out of a bunch of words and text, it's that thing that you slide. So I asked you questions in class, like, what if I just had me? I sign up for this study. You only need me. Well, that's not going to work. That's too few people to answer the question. If you slide that up and say, well, what if I have 1 million people? That's great. It'll answer the question, but that's going to break the budget. They can't afford to enroll that many people. So you're looking for this sweet spot of people to enroll that meets those constraints. That's what they're called. They're called constraints. Constraint number 1 is that's the question. That's the question they have, right? The ultimate question. Sure, if I had 1 million people, I could answer that question. But there's another constraint, and that constraint is I have to fit within the budget. So if I came back to NIH, sometimes I do. I give that bad news to people. Like if you want this one constraint satisfied, I gave that bad news to an early career postdoc at Columbia. You need 100 people, and she said, "Well, I only have a budget for 40 people." I'm just the messenger. I'm just telling you, like, you need 100 people to answer your question. The minimum number you need is 100. You have a budget for 40. So NIH had already told me that they have a budget for about 300. My calculations to answer the question came up to about 148. And I told them still keep the 300. So don't take the 148, take the 300. Why would I tell them that?
Because the more people, the more scientists.
That's right. The accuracy gets better. But then also people can drop out. Like if you enroll 300 and then some of them drop out, you have a cushion. So even though I would tell them not to take the exact answer and then use that exact answer. And then you also have when you're trying to optimize something. And here in the case is minimize cost. That's NIH. Every person they enroll has a cost. And they probably have told you this about cadets at West Point. Each cadet costs $400,000, whatever it is. Like they have a cost per participant. So they're considering all these things. So there's these 3 parts make up, and they call this the objective function. So a lot of your brain is going to be used to take a word problem and pull these pieces out of it. So you have really one thing that you're learning throughout this entire semester in this class is setting up these problems and solving these problems. Kind of like calculus, like in calculus, you're learning about curves. Pre-calculus, I don't know, you're just like open wide, we're going to shove a bunch of methods in. But usually classes have something that they're trying to do. I think higher than this is knowing that this is the method that you're supposed to use given any problem. When I came here the first time, so I actually was here in 1996 to 1998, so I wasn't here the whole time. Came in for those 2 years, I worked for the Army Research Lab, and they asked me questions. They showed me like a picture of a plane that was taken with a new kind of technology way up in the sky, and they asked me to fix the picture of the plane. I was like, oh boy, I don't know how to do that. I have no clue how to do that. So at that point in time, I don't think I was mature enough to figure out, like, pull the right method to solve this problem. Today I would. I would probably know, like, where to start. But that takes a lot of time to get experience to do, to kind of sit down and say, given any problem, figure out how to solve it. That's not usually the way. I think at your level, you're not going to be able to do that just because of experience. You don't have a tool bag yet. So. All right. Any questions about this? More to come on this. So I'm kind of like, I asked if the prepsters in class, how many of you in class already know how to use Excel? Decent? All right. So that's what we're going to do. I think we're going to have to use Excel in here, which is great.